G'day everyone, I'm Lachlan and this is my colleague here Brian. I think we gave a talk back in probably about January, but I'm not exactly sure which month it was, where we're starting off down the MicroPython path with the Propeller 2, which is now sort of limitedly available while they do a respin of the silicon. So we've actually got MicroPython up and running now because there's a guy called Eric Smith in Canada who had who was writing a RISC-V emulator, working on it. And so because he had the RISC-V emulator, actually getting MicroPython up and running using a just-in-time compiling technique was relatively straightforward. So quite a simple process apparently to get going. Not particularly fast, a fair bit slower than the other MicroPython options out there, but it doesn't really matter for us at this stage. We're just interested in sort of using it as a way of getting access to the smart pins, which are a big feature of the Propeller 2. They've got some pretty amazing analog capabilities, and also some features I don't think I've seen elsewhere in micro, such as being able to drive a DAC output at the same time as reading back an A to D on the same pin. So you can check for things like loading, like whether you've got a monitor plugged in, or if you've got some sub-circuit, check what current is drawing and that kind of thing. So some really interesting features on the Propeller 2. It's like the Propeller 1, it's still got 8 cores, and that's probably going to be a bit of it's kind of the bottleneck we're likely to hit first, I guess. What we're demonstrating tonight is using some of those cores in addition to the one core which is running MicroPython, and so we've got 2 cores running VGA output. So we've got the REPL here, and we've got the like a sort of a live memory map of what's happening. So this is a Propeller 2 core outputting video, but it's watching the main memory area, which is mostly filled with MicroPython. And so we'll demonstrate in a moment when you bring in some MicroPython code, what happens is it gets kind of digested by the system, and because it's not super fast, it's actually quite funky to watch live and see how it all gets absorbed. We've got a couple of other things hooked up. So we've got 2 VGA screens. We've got a wireless keyboard over here which we'll use, which is on a USB, running again in a separate core. And then we've got a couple of analog. We've got an analog joystick, a lot like the one Mark was showing off, for moving around that memory map, so we can kind of scroll around and see what MicroPython looks like, I guess. We've also got an encoder, but I don't think we're doing anything much with that. The MPG. Yeah. So.
Lachlan, sorry. I think it's pretty cool just to make clear that there's no PC here.
Yes, sorry, I should have mentioned.
It's just a Propeller 2 board.
Yeah, so it's self-hosted.
It's inspecting itself.
Yep.
That's what that display is.
Yep. And there's no PC, so
the keyboard input is done by itself, and the output for the rep is done by itself. There's no PC
thanks for clearing that up. Yeah, Damien. It's so self-hosted, meaning literally it's all running on it. Ironically, we just need the PC to boot it initially, and then we're kind of, it's just a sort of a power limitation where it needs to enumerate on the FTDI. But that's the only reason we had the laptop out. And so if we hit reset from now, it should keep running, I believe, but I'm not going to try it right now. Anyway, so this is the REPL, and we're just running that. That's a VGA cable back to the Propeller. The new version, which is coming out in July, the Silicon Respin, will have HDMI on it as well. So you should be able to have multiple HDMI monitors if you want to, or more likely you'll probably want to use the cores for other things rather than have lots and lots of screens. So to get into paste mode, Control E. And now Brian's hooked up some internal pasting code, so it's sort of basically, at the moment it's sitting on the Propeller 2 side of it, and this is actually pumping it in through the serial REPL into the MicroPython cog, because we've kind of got, it's just a binary blob, the MicroPython thing, which we've got from Eric. So when we get F11, it'll spool the code in, and you can see it's a lot like modem days, good old modem. We reckon that's about 2400 baud, but we'll take.
But you should be able to see
guesses.
activity.
Oh yeah, so on the live you can see MicroPython starting to fill up. That's the kind of heap area, I guess, Damien. I'm trying to get the terminology right.
So each character there is a block of how much memory?
512 bytes per character. Yeah. Yeah. And it's, I can't remember, is it 3,000 lines or is it 500?
Oh, that's 500.
That's about 500 lines. Right, so that's pasted into serial, and then we control D to, okay, now the thing to watch at this point is the digestion of the code. So when we go control D, you see how it's sort of eating, the white blocks are changes, so when there's a change you see a white flash, it's got a short persistence. And I should explain, the C code is basically the MicroPython code as opposed to the working heap. The blue, the cyan and the yellow are the video buffers, so that block of memory there is actually, and you can see the changes are actually, basically it's recording itself changing, driving its own video out. So that's what those two small, they're about 5K in size. So you saw the thing digest, and now that's actually in the MicroPython. So if we just go tab, you can see this number of functions which have been brought in through that code paste. Now from here, we run. What do we do? The factorial kind of thing. So if we do a factorial of 800. You'll see over here it kind of chew up most of its memory, isn't it? I think it's about. So you can see it sort of working away, and later we'll go back and scroll through it. Then you can see the output there, where it's dumped the resultant output. So that's kind of where it's at now. We've got the thing working quite solidly. We will come back at some point and work on compiling MicroPython using other compilers and things like that to see if we can make it faster than going the RISC path, but it's not really a priority now that we've got this kind of working and we're hooking up to all sorts of different things. This is good fun at this point, and then compilers probably aren't good fun, so we'll leave that for later.
Can you import GC?
Yeah.
And that?
Yeah, so Brian, maybe if you just grab the joystick and scroll around. So this little plus cursor kind of thing is the memory that's being expanded down the bottom, the block. And so if you go back up in the early part, you should see the code, which got pasted in. Oh, it's the digested code now, isn't it? Yeah, true. So what's happening there, there's an analog joystick like the one Mark brought in tonight, which has got just the X and Y values are read in the 0 to 3.3 volt inputs. And the Propeller 2's got 64 smart pins, and so doing an analog input on any of those pins is quite trivial. And so we're just using those inputs to do a kind of poor man's mouse at this stage. The USB side isn't really super, still got a few flakes with regard to, actually the keyboards have been good, but the keyboards except for this one have been good, but the mice are still, yet to be sort of patched in properly. So, so that's what we've got going. From here we'll probably concentrate on the sensors side of it. Just an update really. We'll keep working on this in the background, and Brian's been also working on a debugger which is currently in Python hosted on the PC. One of the things we'll probably look at doing next is putting that onto something like a PyBoard D maybe, so that you can then debug this, and then eventually if this gets enough memory we could look at putting the debugger inside as well, so then you've got self-hosted coding. That's what we haven't done the editor. So so I heard talk tonight, you're talking about a file system like a little FS, was it? Is that right? Yeah, so we probably should have a look at that as well, because we're kind of at the same point where we're trying to think how do we deal with the code. So Brian's also put an editor inside the development thing, and this is just working on memory. There's no file system as yet, but it's a reasonably, it's starting to get useful. That's the code which was brought in earlier on, and as you can see, it's got some colorization under the words, that's actually running in a Propeller 2 cog at the moment rather than on the MicroPython side, and so that's what gets brought across by serial. But having the editor in the Propeller 2 side makes it just more portable for us. That's the only reason we did it in there. Otherwise, we could look at, is there a PYE or something? There's a couple of Pi editors which might be suitable as well. But it's nice and fast, you know, like you've got a decent response speed and all that by having it on the Propeller side rather than the MicroPython side.
And so, just to confirm, when you pressed F11 or whatever it was before, that brought in whatever was in that
code.
editor.
Yep,
That's
it.
amazing.
Yeah, well, it's kind of amazing, yet it's kind of just what we used to do. You know, years ago, you kind of have your Commodores or whatever. You know, kind of had the code locally, and so it's a nod to those kind of days, but with something which will be able to drive HDMI and USB. Like the USB thing looks like it's taking a cog to do both mouse and keyboard, I think, or it's looking that way.
2 cores at the moment.
But you can have, there's a
Can
lot
have
of
one.
USB, you can have one every couple of pins, like it just, you know, so you could have many USB devices and things. But yeah, with suitable drivers and whatnot. Yeah, so that's where we're kind of at, but yeah, I think that's escape to get out of that. Right?
Yep.
Yep. What else have we got? Any requests? Demo. What is
Demo 3.
Demo 3?
Demo 3.
Do I have to dump something out?
S1.
Oh, it's spring one. Okay, demo 3,
Bracket.
brackets,
S1.
S1. Right. There we
This is
go.
colour as well.
But, can we do S2? Is that right?
If you do F off, it'll turn this one. Probably a big choice. F dot off.
F dot off.
The brackets should turn this off.
Right.
And then you can do the same demo on S2. It should run on that one.
Is that just, it's got the green cursor, is that off, or is that...
Yeah.
Yeah, it's stopped.
If it
has
stops
stopped
flashing,
it.
yeah.
Okay, so demo 3
S2.
to screen 2.
Used
Right.
3.
Oh, did
There
I?
we go.
Sorry, I've got the demo instead of demo
That's
3.
another demo anyway.
Yeah, that was
That'll
a
do.
precursor. So demo 3, yeah.
Yeah.
Yeah, so screen 2. We have no idea what the proper streaming names are at this point. There's probably, I don't know, does MicroPython have kind of console-like names, like TTY or whatever, or screen? Not really.
Hasn't had this concept.
We'll try. We probably keep it that way, yeah. Yeah. So yeah. So just directing output to different screens. So the screen, the VGA thing is quite a compact bit of work that Brian's put together, and so it's not only got the kind of screen driving code, it's also got some functions where it emulates a serial terminal basically with colouring, you know, and things like that, and keyboard, and a couple of debug commands and things packed in there. So yeah, but all in a cog. The cogs are quite small. They're only I think it's 4 kbytes of memory in each cog in the core. So that's for general purpose registers, which can be used as code or data or yeah. So it's an interesting beast.
So your font is in the screen driver code.
Yeah.
Yeah, that's right, isn't it? Yes, in
Yeah.
the LUT table.
Yeah, so it's not sitting in the main memory at all. It's built into the cogs. So
Yeah, the text buffer.
the memory split in 2 parts is what they call the cog memory, main memory, and then there's what they call LUT, which is lookup table, which is universal. You can put code in there, or you can put any sort of data, and that's why I've parked the font data is up in there, and kept all the core stuff just for doing the screen. But the video is being generated on the fly. So what it's doing is it's grabbing the ASCII data, looking it all up in the font tables, and then generating a bit stream, and then it gets passed to the Propeller 2 has what they call a streamer, sort of like a DMA type thing where you point it to memory and it just streams it out at the clock speed that you nominate out straight onto the DACs. Every pin has a DAC potential on it, so it just sends out the RGB data and H-sync on 4 pins, and the V-sync is just done just with an I/O port, just in software. So there's no video hardware as such. It's just building the data and then just point to it and it just sends it out. And it's just once you load it up and send it off, then you can go off and you can start preparing the next video line. And but yeah, every pin is identical. There's no function on one pin that you can't do on another. They're all identical. They've all got analog in, out, data in, out, digital in, out. And the smart pins that Lachlan was talking about, there's a lot of timer functions, pulse width modulators, and pulse counting, pulse measurement.
Yeah, so every pin's a smart pin.
They're all the
So,
same.
yeah, it's a kind of a...
Sort of a sub
The
processor on
designer
every
of the
pin.
chips averse to, you know, not having it kind of symmetrical or universal. So yeah, it's kind of
Yeah.
good non-blocking kind of design, I guess. Yeah. So there you go.
Good.
We said we'll be quick, you know. So yeah. Any questions or?
What sort of rate does your VGA run at? Yeah, crank it right up to.
Yes.
That's 640 by 480, 60 hertz there. You can go.
We've
I
had
think
10,
that-
1920 by
Yeah, we've had 1920
40,
going.
40 go, but you don't have enough RAM for it, you know. So you can have
Yeah,
basic, you know, but from a frequency, from a driving point of view, that's about where it goes out. And I think we tried to get to 4K, didn't we? But it was
Yeah.
it's a limitation of the VGA interface more. We bought a 4K monitor thinking, okay, here we go, you know, and it just
Needs
it
HDMI.
doesn't take 4K on VGA ports for, you know, obvious reasons. So. But I think it might have done 25. Did we get 2560 going? It's like 2560 by 1440 or something like that. It's kind of where we topped out. And yeah, I mean the chip can be overclocked to, I think we got up to about 372 or something like that megahertz, and so
It's only spec'd at 160.
yeah, Spectre 160.
And we got
overclocked
with dry
slightly.
ice, we got it to 372.
Yeah.
That's a lot of overclock.
Yeah. We're hoping, we hope so. Yeah, just a nice little healthy cooler, or just a very short demo. Big heatsink short demo would be the key to it. Yeah.
It's good.
Yeah. So yeah, we'll just leave it running, and if anyone wants to have a play, Damien can break it. You know, I'm sure he knows that. I think we fixed some of the things we were looking at last time, Damien. The tab completion and stuff like that works now.
Floating point.
Floating point. I think we had floating point in. I think. Yeah, 2 points. Correct.
Hardware floating point?
No, there's no. There's a thing called a cordic. So you've got basic floating point in the MicroPython soft code. Hardware floating point. There's kind of a thing called a cordic generator, which a cordic calculator, I guess you call it, for calculating, sine, log, all those kind of trigonometric functions, square root, all that kind of stuff. So it's a 56-stage pipeline kind of abacus, which pumps out. You can sort of submit inputs and then go off and do our stuff in your code and wait. That 36 clocks later. 36 clocks. Sorry. Later you can pick up your results. So it's good for coordinate rotations. We did a sort of a pure native P2 demo where we had a spinning demo, I guess you call it, and that was our some test thing when we're overclocking it to make sure it was still running. We basically run that as a good exercise. So there's kind of limited or an unusual kind of there's like a lot of things. There's just a sort of a different way of doing things with the propeller too, and some of that stuff's good and some of it's kind of bad. But I think from MicroPython, because MicroPython sort of complements it so nicely with all the input stuff like the floating point and all that, which is already taken care of. Combine that with the hardware and the smart pins and things, it's gonna be quite a potent little setup, I reckon. Yeah, and so we're just going to wait till July for the chips, the final chips, and in the meantime we just play with this. Yeah. All right, there we go.
Well, thanks.
Yeah, no worries.
Since the people are complaining that
Oh, yeah.
At least this one's covered, you can see it.
it is very cold, very cool.